Hello everyone, welcome back to my YouTube channel Chemistry Pocket. I am your chemistry mentor Sreelatha. In this video, I am going to give some tricks to memorize axial lengths and axial angles of 7 primitive unit cells in solid states of class 12th. Let us start the class. First, let us see what is meant by unit cell. So, unit cell is nothing but the smallest unit which can form crystal lattice after repetition is called as a unit cell. The smallest unit which can form a crystal lattice after repetition is called as an unit cell. The smallest unit which can form crystal lattice after repetition is called as an unit cell. That means the small units, if we repeat those small units, we can form a crystal lattice that is called as an unit. That small unit is called as an unit cell. Now let us see the diagrammatic representation of an unit cell and also crystal lattice. So let us see the unit cell. So this is called as a unit cell. So by repeating these units, we can get a crystal lattice. How? Let us see here. So one more unit cell we can draw here. So this is also one unit cell. So first this is an unit cell and next this is also one unit cell. And next also we can draw the unit cell. It is a one more unit cell. Next sorry, this is not there. So see here, this whole arrangement we can call as a crystal lattice. This is called as a crystal lattice. How we are getting this crystal lattice means by repeating the small units. So these small units are called as a unit cell. This is called as a unit cell. See here, this is one unit cell and it is also one unit cell and also unit cell. By repeating these small units, we can construct or we can form crystal lattice. That small units is called as a unit cell. The repeated small units are called as a unit cells in a crystal lattice. So it is an example of that is an explanation of an unit cell. So unit cell is nothing but the smallest unit which can form crystal lattice after repetition is called as an unit cell. Sorry. The smallest unit which can form crystal lattice after repetition is called as a unit cell. So these are the small units. By repeating these units, we are getting crystal lattice. So this small unit is called as a unit cell. And we can explain the unit cell with a general example also. So take a wall. Okay. So take a wall. Suppose assume a wall. So how we can construct a wall means with the help of an bricks. With the help of an bricks, we can construct a wall. So here, these small units, that means these bricks are called as an unit cells for a wall. Okay. These small units or bricks are called as an unit cells for a wall. So wall contains number of bricks and by repeating those bricks only we can construct a wall. So here that is nothing but the total wall. That means here wall can be considered as an crystal lattice and the bricks can be considered as a unit cell. By repeating the small units, we can construct a crystal lattice. So those small units in this example we can take it as an bricks. So here bricks are called as unit cells and the wall is called as a crystal lattice. It is a general example of a crystal lattice. Now let us see the trick to write the axial lengths and axial angles of primitive unit cells. 7 types of primitive unit cells. So before that, one small request is there from my side. So if you like my explanation and also my teaching, So please like my videos and subscribe my YouTube channel, because I am putting my efforts to make chemistry as simple as possible, because most of the students will feel difficulty in learning chemistry. So that's why I'm putting my efforts towards make chemistry as easy as possible. So that's why. So please boost up my efforts by liking my video and by subscribing my channel. And if you want to give any suggestions or any queries is there, so please post those queries and suggestions in comment section. Now let us see the tricks to memorize the axial lengths and also axial angles of 7 primitive unit cells. So crystal lattice, axial lengths and axial angles. So to write the crystal lattices, axial lengths and axial angles, so I am going to give the trick as cute our mother. So cute our mother. First let us write the 7 primitive unit cells first by using this code. Okay. In this cute, first CU represents cubic. Simple cubic or cubic. The first unit cell name is cubic. And TE represents tetragonal. Tetragonal. And next OUR means orthorhombic. And next MO means monoclinic. T, triclinic. Next HE means hexagonal. R means rhombohedral. Cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, rhombohedral. So these are the 7 primitive unit cells. Now let us see how we can write the axial lengths and axial angles for these primitive unit cells. Okay. To write this, so first of all we had to write as numbers as 0, 1, 2. Next here also 0, 1, 2. Next 2. Okay. 0, 1, 2, 0, 1, 2. Next one is 2. So just put this number. Why means I will explain now. So axial lengths. So axial lengths are there means A, B, C are there. So if all are equal means that will indicates with 0. So 0 means A equals to B equals to C. Sorry. A equals to B equals to C. So axial angles A equals to B equals to C. So if 0 is there means all lengths are equal. All sides are equal. Next 1 is nothing but. So 1 is unequal. That is A equals to B is not equals to C. A equals to B is not equal to C. And 2 is nothing but A is not equals to B is not equal to C. That means no axial length is equal. Again 2 is there. A is not equals to B is not equal to C. And 2 is nothing but A is not equals to B is not equals to C. 1 is nothing but A equals to B is not equals to C. 0 is nothing but A equals to B equals to C. So these are the trick to write the axial lengths of 7 primitive unit cells. Okay. 0, 1, 2, 0, 1, 2, next 2. From top to bottom 0, 1, 2, next bottom to top 0, 1, 2. Next the middle monoclinic also contains 2. Okay. 0 means all lengths are equal. 1 means one length is unequal. And 2 means all are unequal. So by following the trick we can write A is equals to B equals to C like that. Okay. Next axial angles. So for axial angles, for cubic, tetragonal and orthorhombic, for these three, alpha equals to beta equals to gamma equals to 90 degrees. Okay. For these three, alpha equals to beta equals to gamma equals to 90 degrees. Alpha equals to beta equals to gamma equals to 90 degrees. Alpha equals to beta equals to gamma equals to 90 degrees for these three. For monoclinic, mono means single, that is one is unequal. What is that one? Alpha equals to gamma equals to 90 degrees and beta is not equals to 90 degrees. Beta is not equals to 90 degrees. And triclinic, tri means 3. 3 are unequal. So alpha is not equal to, beta is not equals to, gamma is not equals to 90 degrees. All are unequal. Alpha equals to, so alpha is not equals to, beta is not equals to, gamma is not equals to 90 degrees. And next hexagonal. Hexagonal is nothing but alpha equals to, beta equals to 90 degrees and gamma equals to 120 degrees. Hexa. That means some extra angle is there, that is 120 degrees. Gamma equals to 120 degrees. And rhombohedral. For rhombohedral, alpha equals to, beta equals to gamma, but these all are not equals to 90 degrees. Alpha equals to beta equals to gamma. That means three angles are equal, but those three angles are not equals to 90 degrees. They cannot show 90 degrees bond angle. Okay, that means axial angle. So this is the way to write the axial lengths and axial angles. So to write the axial angles, cubic, tetragonal and orthorhombic all are having alpha equals to beta equals to gamma equals to 90 degrees. For monoclinic, one is unequal, that is beta is not equals to 90 degrees. And for triclinic, 3 are unequal, alpha is not equals to, beta is not equals to, gamma is not equals to 90 degrees. And for hexa, one is extra angle is there, that is gamma is equals to 120 degrees. And rhombohedral is nothing but alpha equals to beta is equals to, gamma is not equals to 90 degrees. So in this way we can memorize the 7 primitive unit cells and their axial lengths and also axial angles. So let us see some model questions of this topic. Suppose in this question they given, read the question first. The parameters of the unit cell of a substance are A equals to 2.5, B equals to 3, C equals to 4.0 and axial angles are alpha equals 90 degrees, beta equals 120 degrees and gamma equals 90 degrees. The crystal system of the substance is, it is nothing but, so first see the parameters. A equals to B equals C. A is 2.5, B equals to 3 and C equals to 4.0. It is nothing but A is not equals to B is not equals to C. A is not equals to B is not equals to C. So what is there here? A is not equal to B is not equal to C means it may be orthorhombic, monoclinic and triclinic. Okay. From these three we have to choose monoclinic and triclinic. In these options we have monoclinic and triclinic. So from these two, and again axial angles are given as alpha equals to 90 degrees, beta equals to 120 and gamma equals to 90 degrees. It is nothing but alpha equals to gamma equals to 90 degrees and beta is equals to 120 degrees. So beta equals to 120 degrees is nothing but it is hexagonal. So for hexagonal, so see here, A is not equals to B is not equals to C. The first point is A is not equals to B is not equals to C. Okay, A is not equals to B is not equal to C is there. And angles are alpha equals to gamma equals to 90 degrees and beta equals to 120 degrees is there. Okay. So A is equals to, A is not equal to B is not equal to C is nothing but either it may be orthorhombic, monoclinic or triclinic. So in the options we have only monoclinic and triclinic. So from these two options only we have to select monoclinic and triclinic. So in this monoclinic and triclinic, so which is having alpha is equals to gamma equals 90 degrees. So this one, that is monoclinic, alpha equals to gamma equals to 90 degrees. And what about the triclinic? It is alpha is not equals to beta is equals, not equal to gamma is not equal to 90 degrees. So that's why, so we can't go for the triclinic. So go for the monoclinic. For monoclinic, beta is not equals to 90 degrees. That means it may be 120 degrees or 180 degrees, whatever it may be. So it is not equals to 90 degrees. So in the question also they given as beta is equals to 120 degrees. They won't give beta equals to 90 degrees now. So that's why we can choose the option as monoclinic. So A is not for monoclinic, A is not equals to B is not equals to C and alpha equals to gamma is equals to 90 degrees. Okay. Beta is not equals to 90 degrees. So here beta is not equals to 90 degrees. That means it is nothing but beta is not equals to 90 degrees. Beta equals to 120 is nothing but beta is not equals to 190 degrees. So this is the correct answer. Monoclinic is the correct answer for the question. Next I will give one more question. So let us see the next question. Which primitive unit cell has unequal edge lengths? That is nothing but A is not equals to B is not equal to C and all angles are different from 90 degrees. So A is unequal edge lengths and also angles are different from 90 degrees. Okay. So for this one, take that read the table first. So first one is unequal edge lengths. It is nothing but A is not equals to B is not equals to C. A is not equals to B is not equals to, again orthorhombic, monoclinic and triclinic. From these three only we have to select. And here all are not equal to 90 degrees. So what is the answer? See here. A is not equal to B is not equal to C. Okay, these three are there. And all angles are not different from 90 degrees. Different from 90 degrees means those are not equals to 90 degrees. So 90 degrees is there. So here this one, that means triclinic. Alpha is not equals to beta is not equal to gamma is not equals to 90 degrees. So option is triclinic. So this is the one more question, test yourself question. So which primitive unit cell has unequal edge lengths, equal edge lengths and all angles are equals to 90 degrees. So try to answer this question and post that answer in comment section. Thanks for watching and please subscribe my channel Chemistry Pocket.